Well, welcome back. We've recently talked about the law of detachment and the law of syllogism, and we learned how to do some basic proofs using equality and congruence properties. So in this lesson, we are going to prove and apply some theorems about different kinds of angles. And a theorem is just a conjecture that can be proven true, and we're going to go ahead and start with some theorems and then go ahead and do some proofs um, to show that they are true. So here's our first theorem, the vertical angle theorem, and it says vertical angles are congruent. So 1 and 3 are vertical angles, 2 and 4 are vertical angles. We need to prove that vertical angles are congruent. To do that, we need to go ahead and write a hypothesis and a conclusion. And our hypothesis would be if two angles are vertical, our conclusion would be then they are congruent. So the hypothesis becomes our given statement. If we have angles that are vertical, our conclusion is what we need to prove to be true. So we will be using mostly two-column proofs to do that. I am going to show you what a paragraph proof looks like, but we probably won't be using that format very often. So here's our vertical angle theorem. So we're given that angles 1 and 3 are vertical angles. We want to prove that angle 1 is congruent to angle 3. So we start with our given statement, and then our second statement is to say that angle 1 and angle 2 are supplementary, okay, and angle 2 and angle 3 are supplementary, and that's because they both form linear pairs, and linear pairs are supplementary. Remember, linear pairs share a common side and they form a straight line. So then we can go ahead and say the measure of angle 1 plus angle 2 is equal to 180. The measure of angle 2 plus 3 is equal to 180, and that's just the definition of what supplementary angles are. So from there we can actually say, now take a look at what happens here in step 4. We can say that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus angle 3. They both equal 180, so they must equal each other. So 1 plus 2 right here comes from the first part, and then we just get rid of the 180s and set those two equal because they're equal to the same thing. And that's called the transitive property. Two things that are equal to the same thing are equal to each other. So next we can say angle 1 is, the measure of angle 1 is congruent to the measure of angle 3, and that's just getting rid of this measure of angle 2, and that's subtraction. If we subtract that from both sides, then it's gone. So that's the subtraction property of equality. So lastly, we can say angle 1 is congruent to angle 3. Measures that have the same, angles with the same measure are congruent. So that's kind of the process you're going to be going through. Here's a shorter one for you. It says using the vertical angle theorem, just using that to find the value of x in some problems. So if they're vertical angles, we now know that they are congruent. We've proven that to be true. So we can go ahead and use that theorem to solve problems. So we know 2x plus 21 must be equal to 4x. Subtracting 2x from both sides, we get 2x equals 21, or x equals 21 over 2. So how about the second one? Let's go ahead and work through that one together. The second one says, what is the value of x? Well, we can go ahead and set those equal. We can say 3x is equal to 2x plus 40. And then we want to go ahead and subtract 2x from both sides. And when we do that, we're left with x on one side, and the x's on the other side actually drop out. So we get x on the left is equal to 40. Okay? So, proof using vertical angles theorem. If we're given angle 1 is congruent to angle 4, can we prove that angle 2 and 3 are congruent? So, we're given 1 and 4 are congruent. We want to prove 2 and 3 are congruent. So, here's our given statement. So, the first thing we're going to do is we're going to say angle 4 is congruent to angle 2. We can use that vertical angle theorem now. Vertical angles are congruent. So now if you look at what we have here, we have angle 1 is congruent to angle 4, and angle 2 is also congruent to angle 4. So hopefully you're seeing we have a transitive property going on here. So angle 1 and angle 2 must be congruent to each other by the transitive property. And then statement number 4 says angle 1 is congruent to angle 3 because they're both vertical angles. So look what we have again. Angle 1 is equal to angle 2. Angle 1 is also equal to angle 3. So now we can say angle 2 is congruent to angle 3 by the transitive property, which is what we were out to prove. So here's another one. Go ahead and pause the video and see if you can try to go through this one on your own. I'll give you the answers when you come back. All right, I hope you took some time to go ahead and try that. This one says use the vertical angles theorem to prove the following. We're given angle 1 and angle 2 are congruent. So that's where we always start, is with our given statements. We want to prove all 4 of these angles are congruent. So let's go ahead and start. So we know 1 and 2 are equal. We can say 1 and 3 are equal because they're vertical angles. So if 1 and 3 are equal and 1 and 2 are equal, these two are equal to the same thing, so now we can say 2 is congruent to 3 by the transitive property. But now if we have 2 is congruent to 3 and 3 is congruent to 1, we can go ahead and say 2 and 4 are equal. Those again are vertical angles. And now take a look at what we have. We have 2 and 2 is congruent to 3, 2 is congruent to 4, so we can say 3 and 4 are congruent. So once we know 3 and 4 are congruent, then we've already proven that 1 is congruent to 3, so they're all congruent to each other. 1 is congruent to 2, that was given. We proved that 2 is congruent to 3, and we proved that 3 was congruent to 4. And the second part of this says, how can you prove that they're all congruent without using the vertical angle theorem? Well, we're going to see how to do that in the next slides coming up. So the vertical angle theorem that we proved a few slides ago is a special case of the congruent supplements theorem. And what the congruent supplements theorem says is that if you have 2 angles, 1 and 3, that are supplements, and then you have another pair of angles that are supplements, 2 and 3, where you're using the same angle, 3, then 1 and 2 must be congruent. If 1 and 3 are supplements and 2 and 3 are supplements, then 1 and 2 must be congruent. As long as you're using that same angle, 3, then that will make 1 and 2 congruent. Well, let's see how we actually prove that. And here's an example of a paragraph proof, and I think you'll see very quickly that it's much easier to understand and much easier to follow when we use the 2-column proof. So we're given angle 1 and 3 are supplementary, and angles 2 and 3 are supplementary. Prove that angle 1 and angle 2 are congruent. So here's our proof, and this is in paragraph form. So angle 1 and angle 3 are supplementary because that's given to us. So angle 1 plus angle 3 is 180, and that's the definition of a supplementary angle. Angles 2 and 3 are supplementary, and that's given. So again, the measures of those 2 angles added together gives us 180 by the same definition. Now, we have 2 things equal to 180. 1 plus 3 is 180, 2 plus 3 is 180. So therefore, the measure of angle 1 plus 3 must equal the measure of angle 2 plus 3 because they're both equal to 180. So now we can subtract out angle 3, and we'll get the measure of angle 1 equals the measure of angle 2. And angles with the same measure are congruent, therefore angle 1 is congruent to angle 2. Okay, so again, I think that's a lot more difficult to follow and understand when it's written in paragraph form, but I just wanted to show you what those looked like. Another theorem we have is the congruent complements theorem, very similar to the congruent supplements theorem. It says that if we have 2 angles that are both complements of the same angle, then they're congruent. So if angle 1 plus angle 2 are complementary, meaning they add to 90, and angle 3 plus angle 2 are also complements, then angle 1 and 3 are congruent. Couple other theorems that we're going to be using, I'll just introduce them briefly here. The right angle theorem says that all right angles are congruent. If angle 1 and angle 2 are right angles, then angle 1 is congruent to angle 2. So that's a very short process to go ahead and prove that. And theorem 2.5, if 2 angles are congruent and supplementary, then each one must be a right angle. That says if angle 1 is congruent to angle 2, and angle 1 and angle 2 are supplements, then 1 and 2 must both be 90 degrees or right angles. That's all for this time. We'll see you in class.